about very interesting topic. We have learned about stereochemistry of monosaccharides. Now we are going to deal with conformations of monosaccharide. Conformation is also one of the important characteristics of monosaccharides. So let's know about what conformation actually means. Conformation means structural arrangement. Structural rearrangement is known as conformation. Say for example, this is one structure of this is the structure of certain monosaccharides. So this is structures of certain monosaccharides. This structure can be converted into this structure, these structures. I'm just taking example. So this structural rearrangement is known as conformation. To remember the conformations of monosaccharides, we have to be clear about two basic terms, that is Fischer projection formula, and another Howard projection formula. Okay, so let's go to Fischer projection first. Fischer projection given by scientists called Fischer. So let's take example on the glucose. This is very common example. To remember the structures of the glucose, I will teach you one trick to remember the structures of the glucose. Okay, the glucose is very common example. You should never forget about this structural representations of the glucose. So don't confuse. It consists of C6H12O6. This is the formula. So write 1, 2, 3, 4, 5, and 6. 6 carbon. You fix here CH2OH. Glucose consists of aldehyde, so you write here one aldehyde, C double bond O. Okay, and then you write like this. This is a trick to remember the glucose structure. Here you put OH left, then go to right, then left, left, right, left. Okay, then insert this H. So this is the structures of the glucose. This is a very simplest trick to remember. You write here one aldehyde, you write here this CH2OH, and here left, go to right, left, right, right, another H. This is structures of the glucose. This is open chain. How this is converted in the form of ring in case of Fischer projection, yes, learn. This carries positive charge, and this is highly electronegative. Oxygen is highly electronegative and it carries negative charge. This fifth carbon hydrogen carries positive charge. This carry negative charge. Okay, first carbon and fifth carbon will form a ring. How? Because this carries negative charge, this will react with this hydrogen carrying positive charge. This negative charge oxygen react with this hydrogen positive, and this carbon positive will react with this OH. Okay, and right here CH, other remains unchanged. Here H, OH, other will remain unchanged because there is nothing changing in the conformation. No reaction takes place up to carbon number 4. But in case of carbon number 5, this hydrogen will react with this oxygen, so double bond will break and it becomes single bond, and this O will combine with this OH. Okay, and what happened to this carbon? It carries positive charge. This will react with this oxygen, so you put here blank because this oxygen goes here, and this oxygen you write in the form of a ring like this. Where this oxygen goes, this oxygen is here, and this hydrogen goes where? Here. This hydrogen goes here and break the bond, becomes OH, and this positive charge will react with this negative oxygen, and this oxygen goes right in the form of ring. Here CH2OH remain unchanged. Okay, very simple. In this open chain, this carbon will react with this oxygen, and you write oxygen here, and this hydrogen you write here by breaking the double bond. This is structures of alpha, the glucopyranose. You should write glucopyranose because it comes in the form of ring, so it is the structures of glucopyranose. This is alpha because OH is present in this side. Alpha because this OH, carbon number 1 OH is present in which side? Right side. This is the alpha. The same structure in case of beta. You write other unchanged 1, 2, 3, 4, 5, and 6 here. You remember the trick 1, 2, 3, 4, 5, 6. You remember the trick? Here, right, left, right, right. Here H, here H, here H, here H, and this OH should converted. In case of beta, you write here OH. Here H, you write here H. And in this fifth carbon, you put here, you put this blank and write the oxygen in the form of a ring. Okay, this O will write here in the form of a ring, and this hydrogen should be right in with attached with this O. Okay, it should consist in the left side in case of beta. Okay, in case of alpha, it should be in this side. Other remains unchanged. You put here blank, H goes here, attach here, and O here. This is the Fisher projection formula. How this Fisher projection formula is converted into Howard? You just remember one ring. This is known as pyranose ring. This is a 6-member ring. 6-member ring. Okay, 1, 2, 3, 4, 5, 6. 6-member ring. Here one bond, one bond, another bond, another bond. Okay, you put here this CH2OH. You fix here CH2OH, and here H. You fix this position. Right here 1, 2, 3, 4, 5, and 6. Okay. This is very simple structure. Just draw one pyranose ring that is 5-member consisting of one oxygen bond. Put here carbon number 1, 2, carbon number 1 to the nearest to O. 1, 2, 3, 4, 5, and this 6. 6 you fix this CH2OH. You just put here and ice here. Okay, you fix this 5th position carbon. Other C1 here. This is what? This is C1. This we are writing the structures of alpha. Okay, 1, 2, 3, 4, 5. In alpha, OH in which side? Right side, isn't it? OH is in the right side. Right, you just put down. Left is what? Hydrogen. You just put here up. Okay, left, up. For carbon number 2, left, up. Right, down. Left, up. Right, down. Left, up. Right, down. For carbon number 4, left, up, right, down. Okay, and fix the 5th position CH2OH and H. This is the structures of alpha D-glucopyranose for Howard structure. Howard, you should draw one ring. This is alpha. In this alpha, OH is which side? In the carbon number 1, OH should be down. Down because it is in the right side. Right, you should right side. Right side, you should write in the down. Left in the up. Okay, left, up, right, down. So here right OH you should write down. In case of alpha, OH should be in the down. That means carbon number 1, OH down. This OH you should take reference for carbon number 4. Just take carbon number 4 OH beside. Carbon number 4 OH is also in the down. 1 also down. If carbon number 4 and carbon number 1 are in the same plane means both in the down. So this is the structures of alpha. OH down, carbon number 4 OH also down, carbon number 1 OH also down, carbon number 4 OH also down. Carbon number 1 and carbon number 4 should be in the same plane in case of alpha. Okay, just remember this structure in case of beta also. Same structure will come here. Just remember one pyranose ring. Okay, here 1, 2, 3, 4, 5. You fix here CH2 what? CH2 OH and H you fix here. And other in case of beta, left OH, left should be up and right should be down. Right, down. Left, up. Right, down. Left, up. Right, down, left, up, right, down. So in this carbon number 1, OH is in the upward, carbon number 1, and carbon number 4 down. That means they are in the opposite plane. C4, OH is where? Down. And in the C1, OH is where? Up. That means they are in the opposite plane. Opposite plane. 4 is down, 1 is up. So this is opposite plane. So this is the structure of beta D-glucopyranose. In case of beta, OH should be where? OH should be up. In case of carbon number 1 and carbon number 4, OH should be down. That means other remains unchanged, only this other remains unchanged. Other remains unchanged, only carbon number 1, OH should be down in case of alpha, and in case of beta, that means OH should be in the opposite plane in case of beta, and carbon number 4 and carbon number 1 should be in the same plane in case of alpha. So this much. Thank you. I think you are very clear about Howard projection and Fisher projection.